Today's the presentation is on the debris and mudflow. This is the current applied hydrology research that I'm doing since 2000. We have the outline presentation on the background activities, the achievements, climate change impact, debris flow model, challenges and the way forward. Let me go back to the two objectives of HTCKL. We have 4 functions too, to serve UNESCO. At the moment, on the IWM concepts, we are related to 9 water SDGs from the 17 SDGs. And of course, we are serving within the humid tropic belts. And we do have these principles, structures and governance under the 3 pillars on the economic, equity, environmental, where this is the best part, the most part that we have a problem. Challenges that we need to tackle at the same time, enabling environment, and of course the institutional framework include the institutional memories, activities that related to our hydrology water resources. And we need to balance all this water for livelihood and water as a resource. These are the activities. At the moment, we do have about 7 undergraduates and 6 masters, 2 PhD completed within our applied research projects. We have Alam Sludge project, step solar stills for the water desalination, biomicropore projects to reduce the runoff excess. Phytoremediation technique is one of the eco-hydrological technique. The other one is the gross pollutant trap to calculate the proprietary GPTs that we install within the Klang valleys, about 400 plus, to seek on the life cycle cost for our future improvement. And these are our publications on the water management curricula, as what been mentioned by Dr. Peter Wells just now. The curricula is very important. So this release in late 2017, we published it in 2017. This is another customizing IWM at the river basin level that I've been talking by Dr. Nasir Makno just now. We have a production of journal every year, and this is the one of the example of our technical publication. Ongoing applied and R&D research since 2016 and 2020. This is our current project on development of saltwater index for the highland area. And of course, this is the current projects, debris and mudflow. Mobile flood barrier to reduce the runoff excess from the river, which is more lighter and is very flexible to the public and the community. And of course, last but not least, the re-engineering project, whereby we need to understand what we are having currently by using the model that been available on shelf. All right, the achievements since establishment 1999, we have female 1,636, where male participation about 1,265, so they are balanced. The total will be about 2,901. And those are the list of HTCKL technical visitors up from UNDP Bangladesh. They would like to see how we manage the centers. They would like to develop 1 centers maybe. And APCE just now, Dr. Stapa, before during the establishment. REDA is one of the housing development agencies that also referring to our small demonstration project for the runoff excess reduction, or IWRM. UNESCO Dhaka also came to us to see in May last year. Of course, every time UNESCO Jakarta, Oyo Corporation, one of the Japan companies that are visiting us on the debris and mudflow. So these are the external reviewer meeting last time conducted, moderated by Professor Shabas, Dr. Professor Takli and Dr. Olivia, to audit us on the renewal of the MOA of HTCKL. This is the visitors from ICWM. On these technical visits, whereby we have this showcase study on the ROL project's public outreach program. So we introduced them how we carried out the public outreach program. Of course, due to climate change, just now one of the speakers talking about the climate change impact, we do have these problems. Locally, it's urban heat islands, whereby it's heating up our urban areas. And of course, on the global effects, we have flood issues. So at the same time, this is the scenario that I can show you back in 2010, 2001. This is where Kuala Lumpur is heating up at 11 a.m. And throughout the studies, I proved that the temperature has risen about 1.9 degrees for Kuala Lumpur and 0.9 degrees Celsius for Johor Bahru. So we compare between the green area and urban area. So due to that effects on the floods, we disembarked on this applied research study on the debris and mudflow, where this is one of the cross-cutting local and international activities on the water resources security and sustainability. This is one of the first kind that we received from MLIT Japan, thank you very much, during the working group of hydrology back in 2000 through the WMO. This is the first time that I received the information and guidelines from MLIT itself. And throughout the studies since 2000, we managed to develop one manual. And also, it's also available. Everybody can have a look on the manual of this debris and mudflow, how you can develop the formula and calculations. This is the historical events in Cameron Highlands, basically what we have since back in 1961 to 2014. These are all the recorded, this is official recorded in the newspapers. The minor debris and mudflow, we couldn't get it unless we have it from our software that I'll show you later. So this is the officials, and it was in 1993 we started to have one losses, January 2000, it goes to 6, and then back in 2013 and 2014, it was alarming our minister. So from there, we have the fund provided by the government. So this is the areas. This is Peninsular Malaysia, and this is state of Pahang. And you can see this is a area of Cameron Highlands, about 712 square kilometer, with slope more than 60%, 20 degrees. And the landscape cover area about 10% to 30% slope. Altitude up to 1,600 meters. They are all here in the middle of Peninsular Malaysia. This is normal non-eco-friendly farming practices contribute to siltation, erosion, and landslide in Cameron Highlands. You can see this is how the big boulders came down in 2009, and we have losses, 3 deaths and 4 deaths in 2014 and 2013. But we still have the immediate restructuring of the protection using the structural material, so stabilization and strengthening of the slope. But nevertheless, we need to provide non-structural measures where the objective is to develop a sediment-related disasters warning system, especially for natural sediment disasters only, not landslide, because our department is only catered with the water sediment-related disasters, and is also only the natural disasters. So we try to provide an early warning at the vicinity area in the river system within the district of Cameron Highlands. We try to give a forecast of 7 days and as early as 2-day warning to the public downstream. So this is the software evolution since 2000. Received from Typhoon Committee Working Group of Hydrology, nothing that I have here. And then in 2000, we tried to generate occurrence and non-occurrence event. I think DPRI, MLIT don't know what's this occurrence and non-occurrence event, whereby occurrence is the event that been recorded or found throughout your rainfall analysis. Non-occurrence events is whereby the rainfall is more, but there was no recorded. So all been jumbled up in the first time. During the first time, all been jumbled up. And 2003, we managed to improve some and even in certain phases. 2005, we got more. All these are manually calculated using Excel. But yet, back in 2015, after our ministry was alarmed by those two incidents back in 2013 and 2014, we managed to get some funds. So through that some funds, we have a proof of concept for the phase 1 debris and mudflow version 2. We call it version 2 because this is only the automatic calculations that follows the Excel spreadsheet that I developed before. And currently we try to segregate the landslide, debris and magma failure only to have the natural sediment disasters from 2013 to 2020 approved project by the government through the 5 phases. So the 3 phases currently been approved by the government to have some fund. And current project proposal, we have a 3A and 3B, where 3A is the instrumentation on the additional salt water index through the measurement of pore water pressure using piezometric instrument. This is a basic working rain. This is a half-life period that we have received from MLIT. This is a basic calculation that we have, but concurrently we try to add some more parameters. So this is only a triggering factor for the natural disasters event. So this is a working rain, half-life period. This is a previous rain accumulated for 24 hours, and this is subsequently previous 24 hours accumulated rain for half-life period. This is a normal calculations based on the physics concept. Half-life period. Alright, this is how we develop the catchment models for phase through C. We divide it into 25 sub-catchments, so each model will have its own rainfall calculation, working rainfall and so on. And we develop the hazards and risk area based on susceptibility maps that are available from the other stakeholders engagement such as mineral and geoscience, where they provided us this susceptibility map, and MAT department, meteorological department, we provide us the numerical weather predictions. So this is the example of debris and mudflow monitoring software template. This is online and it is a website model template available in the debris and mudflow. And this is the copyright logo that we have for the Malaysian debris and mudflow modeling. We do have the rainfall analysis for the further calculation, defined curves, and this is a forecasting templates. This is a Google. It is a Google web models that we do have. You can add and you can add any station that you have. So previously we have one of the example in another area, not within the Cameron Highlands, but we managed to put it the data of the different area and try to use this software in order to develop or forecast the disaster. So actually it can be done anywhere in the country. It's just that you have to segregate the events at the right places. This is another example how you set up your triggering critical line, intensity, warning line as you wish, and this is automatic will be done through the software. This is the critical line, this is evacuation line, and this is the warning line that you have. So those are these non-occurrence event that you can see through the software, and those are the officially reported in the newspapers. So this software is able to segregate whether you receive the official disaster event or not, but this software is able to identify actually you can identify the event that has not been reported in the newspaper officially. Alright, this is another method. We try to segregate within, it's not half-life period also, we try to get a quarter life period. So this is how you calculate the working rainfall. All are web-based. So what are the challenges and the way forward? Of course, the parameters, we have to include the new weather prediction and radar. The latest one is the salt water index. Of course, the triggering factor is the rainfall. This is the most culprit factor that we started before. And unfortunately for the radar, within that Cameron Highland, unfortunately we don't have the coincide for radar in Malaysia at all. So far we have we have to depend on numerical weather prediction, even though numerical weather prediction is far up and it's not that promising, but this is the only method that we have to receive the rainfall forecast. But meteorological department has received some fund in order to install satellite image, radar instruments in Cameron Highlands. So fortunately, we have that fund through medical department. So later, the model can be included radar information for the forecast, current weather prediction. So of course, assessment and information are very crucial, and instrumentations like a piezometer, we have to install it correctly. I will show you later. And this is the most important sensitivity maps that be derived by another stakeholders, which came from mineral and geoscience, where we know all those area and soil type and the depth of the laterite or whatever. This is static informations, and the promise, this is challenge, the most challenge, 7-day forecast and 2 days warning. And this is the soil water index been calculated in 2014 for Bertam Valley, and this is the area in Cameron Highland, and this is 2014. It shows that soil water index was 52 when the higher rainfall occurred, and this is 91 when higher event occurs, and also 45. So this is one example in Bertam area. So it shows Gunung Berincang, one of the station available, is far, about 12 kilometers, but nevertheless those are the stations available. But currently we're installing more than 5 stations within the Cameron Highland. Additional 5 more stations, automatic 5 more stations. Another example, for Kuaratala, there's another site where we have these disasters. It shows that about 107 saltwater index can shows that during a high rainfall event here, it shows the disasters happen. This is based on the event really happened 2016 and May 2016 for Kuaratala for different station, Mardi. So this is where the starting point of the hourly rainfall and the soil water index. This is shows Kuaratala having about 100 soil water index that triggered the disasters or natural disasters by using one of the parameters of water index. Alright, this is also the same one, Tanah Rata, and it is relative accurate, not that accurate, but the contents are accurate of the events such as landslide, debris flows and mud flows is relative capacity water retention in the slope. So we, for the pre-assessment, we can say that Kuaratala has a soil water index about 100 and Tanah Rata about 70 values of the soil water index to trigger the natural disasters or sediment related disasters. But it really does depends on contributing factors on the geological and topographical conditions, situation of land development and vegetation. If you look at just now my previous slide, they were everywhere plastic houses for this plantation, so it really fastened the time of concentrations to the rivers. And continuously collect the data and the research correlations. So these are the challenges and the applications. This is theoretically that we followed throughout this the concept that we try to follow, whereby this is the slide plane that will really slide when we have more water in our on the top of our bedrock. So we try to have that calculations on to give the amount of height of groundwater table for the intention of the installation of the piezometric. So we try to investigate what is the water level at the surface layer here on the top of the bedrock. Then when we know the level, we know how to install, how that will be the installation or the piezometric will be. So this is the proposed identification of the water table. We install this piezometric based on the pre-assessment. They are going this next week for the pre-assessment identification of site location for the NIC line. Just now I forgot to showed you. So we are going to install between the neck line gradient changing of point, 2 here and 2 here. So of course after that you know when the water table is here raising up and is comparable with the down here. So this will be the selection, very difficult selection for next week's site visits for 6 stations at least, but we only managed to get I think 2 stations because it's very difficult in Cameron Highland to identify the actual location whereby most of the natural sediment related disasters is not mainly natural disasters, but they are a combination of man-made disruption such as open clearing, you know, and maybe some others issues that been happen in Cameron Highland. So those are the challenges that we have in Cameron Highland and also in this applied research study. And I finish up with a thank you to this WENDI to invite me on this launching event, and thank you very much. And the other one, I want to invite all of you to join our first international conference on ICWR. This is a biennial conference in Langkawi. So please have a look on this website. They are still open. It will be in 27 November to 28 November this year. Thank you very much.